Warning: acetone is highly flammable. Sodium hydroxide is corrosive. Wear gloves when handling them. Hi guys, here is MIH. Acetone, being the simplest ketone, is a great solvent and reactant for many kinds of organic reactions. Most people can obtain it easily, but sadly it isn't that available in some regions in its pure form. Today I'll synthesize acetone via the retro-aldol reaction of diacetone alcohol, another industrial solvent. This is basically reversing the commercial synthesis of diacetone alcohol from acetone, so it is useless in practice except for home chemists, but serves as an excellent example of retro-aldol reaction and use of dynamic equilibrium to control reactions. The setup and the reagents of the reaction are extremely simple. I weigh out 100 grams of diacetone alcohol and pour it into a flask. Next, I weigh 2.5 grams of sodium hydroxide, dissolve it in 100 ml of water, and pour it into a flask as well. And that's it. As you can see, the diacetone alcohol has limited solubility in water, making the mixture cloudy. The mixture is then heated gently until the thermometer reads 57 degrees C and large amounts of acetone pours in the condenser. I found it necessary to set the heating manual temperature to 100 degrees C in order to maintain a fast distillation rate. Note that the cooling water reservoir has several ice bags placed in it, as cold water is best used because of acetone's low boiling point. The great thing about this method is that the setup only required minimal interference in the next 2 hours or so, where 500 ml of diacetone alcohol is quantitatively converted to acetone. Now what is happening here? The well-known aldol reaction is a fundamental reaction in organic chemistry, where two carbonyl compounds combine to form beta-hydroxyketone, which then may eliminate to an unsaturated ketone. However, less people know that the aldol reaction is reversible, and the reactants and products are in equilibrium with each other. Acids or bases catalyze the reaction and makes the system reach equilibrium rapidly, but importantly does not change the amounts of each substance at equilibrium position. Now, the industrial synthesis of diacetone alcohol needs to reflux acetone for 4 to 5 hours under a saucer extractor filled with barium hydroxide. From this insane reaction time, you can easily tell that the forward reaction is very difficult, and the proportion of diacetone alcohol in the equilibrium mixture is very low. But a difficult forward reaction implies an incredibly easy backward reaction to decompose diacetone alcohol back to acetone under a sodium hydroxide catalyst. And by continuously removing acetone from the system via distillation, the equilibrium constantly shifts to the acetone side, and eventually all diacetone alcohol is converted to acetone. After half an hour, the readings on the thermometer increased considerably higher than 60 degrees C, meaning that nearly all diacetone alcohol is decomposed, so I temporarily turned off heat and stirring. I then assembled a dripping funnel above the flask and filled it with more diacetone alcohol. By gradually adding diacetone alcohol to the flask, a continuous process is achieved, where temperature is never let above 60 degrees C, so minimal water distills over, improving the purity of our acetone product. When the entire bottle of 500 ml of diacetone alcohol is added through the funnel and the temperature rises above 60 degrees C, the distillation is stopped. The content in the flask is yellow due to byproducts, probably condensation products between acetone and diacetone alcohol. Off camera, I distilled all the crude acetone to purify them and remove water. The final yield of pure acetone is 413 grams, or 88.1 of the theoretical. Since I cut the second distillation when 50 ml of acetone is still in the flask, the reaction yield is very close to 100%, or quantitative. This method, with its very simple reaction setup and quantitative yield, is one of the most cost-effective and efficient methods of obtaining acetone, of course except from buying it, and is perfect for those living in areas where acetone is unavailable. I'll use this acetone in another video to try the heating lamp again. See you soon!